Hello everyone, and welcome to the Safety Artisan, home of safety engineering training. I'm Simon, and today we're going to be looking at how you analyze the safety of functions of complex hardware and software. Okay, we'll see what that's all about in just a sec. So I'm just going to, here we go, get to the right page. And this, as you can see, functional hazard analysis is task 208208 in Mil-Std-882 Echo. And what we've got for today, we have 3 slides on the purpose of functional hazard analysis. And these are all taken from the standard. We've got 6 slides of task description, so that's the text from the standard, plus we've got 2 tables that show you how it's done from another part of the standard, not from task 208. And then we've got update and recording, another 2 slides, contracting, 2 slides, and 5 slides of commentary, which again include a couple of tables to illustrate what we're talking about. So what we're going to talk about is, as I say, functional hazard analysis. So first of all, what's the purpose of it? And in classic 882 style, okay, task 208 is to perform this functional hazard analysis on a system or subsystem or more than one. And again, as with all the other tasks, it's used to identify and classify system functions and the safety consequences of functional failure or malfunction. In other words, hazards. Now, I should point out at this stage that the standard is focused on malfunctions of the system. The truth is, in the real world, that lots of software-intensive systems have been involved in accidents that have killed lots of people, even when they're functioning as intended. And that's one of the short-sightedness of this Mil standard, is that it focuses on failure. The idea that if something is performing as specified, that either the specification might be wrong or there might be some disconnect between what the system is doing and what the human expects. This system just doesn't, the way the standard is written just doesn't recognize that. So it's not very good in that respect. However, bearing that in mind, let's carry on with looking at the task. So we're going to look at these consequences in terms of severity only. We'll come back to that, for the purpose of identifying what they call safety critical functions, safety critical items, safety related functions, and safety related items. And quick word on that, I hate the term safety critical because it suggests a sort of binary. Either it's safety critical, yes, or it's not safety critical, no. And lots of people take that to mean if it's safety critical, no, then, oh, it's got nothing to do with safety. They don't recognize that there's a sort of a sliding scale between maximum safety criticality and none whatsoever. And that's led to a lot of bad thinking and bad behavior over the years, where people do everything they can to pretend that something isn't safety related by saying, oh, it's not safety critical, therefore we don't have to do anything. And that kind of laziness kills people, is the short answer. Anyway, moving on. So we've got these SCFs, SCIs, SRFs, SRIs, and they're supposed to be allocated or mapped to a system design architecture. So the presumption in this, the assumption in this task, is that we're doing it early. We'll see that later. And that system design, system architecture is still up for grabs. We can still influence it. Often that is not the case these days. Okay, this standard was written many years ago when the military used to buy loads of bespoke equipment and have it all developed from new. That doesn't happen anymore so much in the military, and it certainly doesn't happen in many other walks of life. So, but we'll talk about how you deal with the realities later. And they're allocating these functions and these items of interest to hardware, software, and human interfaces. And I should point out, when we're talking about all these things are complex. Software is complex, human is complex, and we're talking about complex hardware. So we're talking about components where you can't just say, oh, it's got a reliability of X, and that's how often it goes wrong. Because those type of simple components that are only really subject to random failure, that's not what we're talking about here. We're talking about complex stuff where we're talking about systematic failure dominating over random simple hardware failure. Okay, so that's the focus of this task and what we're talking about. That's not explained in the standard, but that's what's going on. Okay. And our third slide on purpose. So we use the FHA to identify consequences of malfunction or functional failure, lack of function. As I said just now, we need to do this as early as possible in the systems engineering process to enable us to influence the design. And of course, this is assuming that there is a systems engineering process. And that's not always the case. We'll talk about that at the end as well. And we're going to identify and document these functions and items